Hello everyone, this is page 56, practice 3A, first question. Let's solve this question, which says a piece of metal weighs 50 Newton in air, 36 Newton in water, and 41 Newton in an unknown liquid. Find the densities of the following. A, find the density of the metal. B, find the density of the unknown liquid. Now here in this question, we've got some given. Let's just write down the given here. But before that, let me write down practice 3A, page 56. This is our page in practice. All right, let's start with question number 1. Okay, so what is the given that we have here? The given is, first it says you have a metal that weighs 50 Newton. So that means the Fg, the real weight of the metal, Fg, equals to 50 Newton. This is the first information that we have. And then it says if you put this object into a liquid, into water, the weight will be 36 Newton. So that means this is not Fg, not real weight, this is apparent weight, which I call it F net. And because it's in water, I'll just call it F net W, all right? This W means the apparent weight in water. And this equals to 36 Newtons, all right? And the final information here is when you put this object in an unknown liquid, that means you put it in another liquid. So that means we have another F net. But this F net is for unknown liquid. This is UL, that means unknown liquid. Once you put it in the unknown liquid, the apparent weight will change into 41 Newton. All right, so these are the Fg's and the two F nets that I have in the question. And then I have another extra information, which is the density for water. I know what the density of water is, so I'll just write it next to water. Rho W, I'll just call it rho W. I could call it rho F, which means the density of the fluid, F. But no, I'll just call it rho W, which means the density of water. And the density of water is known. It's 1,000 kilogram cubic meter. This is the density of water, 1 times 10 to the power 3. All right, so the unknown is, the unknowns are, we've got two unknowns. First, A, my first unknown is, it says find the density of the object, of the metal. So I'm trying to find the density, rho O, that means rho of the object, or you can call it rho naught. The density of the object. Let's try to find that. And in order to find this, you have to write down the expression, the useful expression that we talked about, which states that Fg divided by Fb, weight divided by buoyant force, equals to the density of the object divided by the density of the fluid. Now in this case, the density of the fluid that is given to me is the density of water, not the unknown fluid. I'll use the density of the water that I have, because this is known. The density of the unknown liquid is yet unknown. So I'll just use rho W. I'll just use rho W for the case of the fluid. All right, let's see which informations we've got. Well, here I've got Fg, which is 50 Newton. This is known. Okay, this one is not writing. So I've got Fg. This is known. This one, I don't have it, the density of the object, but no problem, because this is what I'm trying to find. So it's okay if I don't have it. What about the density of the fluid? The density of water? Yes, this is also known. No problem here. The only thing that makes an issue for me is the buoyant force. Buoyant force is unknown. This is what I should find. And I'll just find the unknown force, the buoyant force, here in this corner. Let me find unknown force. Sorry, not unknown force, buoyant force. Buoyant force in this corner. How do you find buoyant force? Well, the equation for buoyant force is F net equal to Fb minus Fg. This is an equation for buoyant force. If you put the numbers back in, the F net for water, of course, because we are dealing with water here, right? So I'll use the F net for water, F net W, which is 36. And because your metal is sinking into the water, this is why it has an apparent weight, because it must have sunk into the water. So that's why it's negative. If an object sinks in water, the Fnet it has will be negative. All right, this is something that we've already talked about. And the Fb, which is unknown, I'll just write it here. And then minus Fg. My Fg was 50 Newton. 50 Newton. All right, so I'll take this 50 Newton to the other side, and it will become positive. So my Fb, the final answer here, I'll write it here. Fb, buoyant force, will equal to 50 Newton. 50 Newton minus 36 Newton. Fb will be, my Fb will equal to 50 Newton minus 36 Newton. What will be the number that I get? It will be 14 Newton. So here we found Fb, the buoyant force. It is 40 Newton. So you use Fnet's equation to find Fb, because you have Fnet, you have Fg, you will simply find the buoyant force, Fb. Just make sure that to put your Fnet as negative, because the object is sinking in the water. That's why it has an apparent weight at the first place. Okay, so I guess that's it. Once we have Fb, you will just simply put it back in the equation. Now we have Fb as well, the buoyant force as well. Let's insert it into the equation and find out the real value for the density of the object. And how do you find the density of the object? We'll just simply grab this density of the water and take it to the other side. Because it's in the division, like it's in the denominator, it will become a multiplication. It will go to the numerator. All right. So there you go. Just write down rho naught, the density of the object, equals to. This will stay the same. Fg divided by Fb, weight divided by buoyant force, multiplied, that was a division, it went to the other side and it became a multiplication, multiplied by the density of the fluid, of water. So my Fg was 50 Newton, divided by my Fb, I just found it, it was 14 Newton. You can write down the units at the end, I wrote it here, multiplied by the density of water. And what is the density of water? It's 1000 kilogram cubic meter. So if you multiply all of that together, the number that you should get, let me find the number. So I guess the number should be, let me see. Yeah, the number should be 3.57,000. And what is the unit for density of the object? Because this is what we are trying to find, the density of the object. Well, the unit for it is, because it's density, it's kilogram. It's basically, wait, this is not written well. It is kilogram per cubic meter. All right, this is the final answer. And if you look at the calculation here, this Newton will go with that Newton, so you will be left with the only density, only the unit with density. That's why the final unit will be density. Okay, so I guess that's it. This is how you solve A. This is how you find the density of the object. But then it says find the density of the unknown. Find the density of the unknown liquid. All right, so let me write down another given for me because I found the density of the object. I'll just write it here. The density of the object equals to 3. This is an extra information that I have now since I found it, times 10 to the power 3 kilogram per cubic meter. Okay, so let's find B. B here asks for, it says find the density of the unknown liquid. This is the density of the unknown liquid, density of the UL, that means unknown density. Let's find the density of the unknown liquid. All right, again, you use the same useful expression. This expression here that we used already, we will use the same thing. It's the same steps, nothing new here. Fg divided by Fb equal to density of the object divided by density of the unknown liquid. Let's see which variables we have. We have Fg, 50 Newton. We have the density of the object. I just found it. There it is. We don't have the density of the fluid here, of the unknown liquid, but that's okay because this is what we are trying to find. Even if you don't have it, no problem. This is our aim. This is what we are trying to find. What about the FB? Do we have FB of the unknown liquid? No. We have FB of the water, but we cannot use that. This is the buoyant force of water because I used the apparent weight of water, which was 36. I cannot use this buoyant force here. I cannot put this 14 here because I need to find the buoyant force of the unknown liquid. So I don't have that. Let's find it here in this corner again. Same method, nothing new here. Fnet, this is the equation for Fnet, but this Fnet will be the Fnet of the unknown liquid. I will not use the Fnet for water. I'll use the Fnet for the unknown liquid, UL. And this equals to FB minus FG. As you know, this equation, we know it already. My Fnet of the unknown liquid is 41. But again, because it's sinking, because the metal is at the bottom of the liquid, of the unknown liquid, then the sign will be negative, all right? The sign is negative. Now FB, you just put it here, and FG minus, what was FG? FG was 50 Newton. Yeah, right, we had FG, which was 50 Newton. Okay, so take this negative 50 to the other side, and this is what you get. FB equals to 50 Newton. Now it's positive because I took it to the other side. The negative sign will change it to positive. Minus 41. Minus 41. So FB will be 9 Newton. This is the buoyant force of the unknown liquid. Now I have this buoyant force of the unknown liquid. All right, so I think I have all the necessary parts. I have FG, I have the density of the object, I have the density, I have the buoyant force. The only thing that's left is to find the unknown, which is simple. Well, one way to do that, now I cannot just take this density of the object and take it to the other side and to find the density of the unknown liquid. I cannot do that because the density of the unknown liquid is in the denominator. In order to take the density of the unknown liquid to the numerator, there's a way we can do that, which we call it the cross. Just cross this with that and this with that. You just make a cross, okay, an X shape, just like that, okay? Make an X shape, multiply FG by density of the unknown liquid equal to multiply density of the object by the buoyant force. Okay, let's do that. It's okay if you multiply this first or this first, nothing changes here. You can multiply the numerator with the denominator, or you can multiply the denominator with the numerator, or you can do it here, first do the numerator, no difference. Just multiply those two together. Let's say that we multiply this one here by that one. So the density of the unknown liquid multiplied by Fg equal to, now we got to the equal sign. Let me write the equal in a different color. There you go, equal to, and then multiply Fb, buoyant force, by the density of the object. So here we've got Fb multiplied by the density of the object. All right, so what is the unknown here? This is my unknown. This is what I'm trying to find. So I'll take this one to the other side. And because it's a multiplication, once it goes to the other side, it will be a division. So the final equation will be the density of the unknown liquid equals to Fb divided by Fg, because this Fg went to the other side, okay, multiplied by the density of the object. This is how it looks like. Alright, so this is the final equation. We did this cross because the density of the unknown liquid was in the denominator. We had to take it up. Alright, now it's in the numerator. And it's alone. We singled that variable out. Okay, so let's insert the numbers. Fb, I just found it here. It was 9 Newton. Multiplied by the density of the object, which we found in the previous question, which was 3.57 times 10 to the power 3. 3.57 times 10 to the power 3 kilogram cubic meter. Divided by Fg, and my Fg was 50 Newton from start. So there's n's, those newtons will cancel. Okay, so let's put this in the calculator and see what is the number that we get. Let me see. So I guess if you insert this in the calculator, the number that you should get is, yeah, 643. It is simply equals to 643, and the unit is the unit of density, because this is what we are trying to find. We are trying to find the density of the unknown liquid. So it will be kilogram cubic meter per cubic meter. This is how you find the density of the unknown liquid and the density of the object using this useful expression. The only challenging part here is that you have to find FB in your little corner, FB for water and then FB for the unknown liquid, and then to know how to do this cross, how to take out this density of the unknown liquid into the numerator, how to just cross it and save it from the denominator. And that's it. I hope you understand the lesson. If you have any questions, just let me know in the comments or let me know at class. We will try to simplify this down even more if you think you have any problems understanding the lesson. Alright guys, good luck.